Hey guys, welcome back to another video. In this video, we're going to be learning about straight line graphs. That is the sixth topic from the Add Maths syllabus. So, the first thing we will learn about is finding the length between any two given coordinates. Let's say I have coordinate P, I have coordinate Q. How do we find out the distance between these 2 points? What is the distance between point P and Q, given they have the coordinates x1, y1 and x2, y2? Now we can use a simple formula to find the distance directly, which is the magnitude between both of these coordinates. So the formula says the distance between PQ or PQ mod is going to be given by root over x2 minus x1 whole square plus y2 minus y1 whole square. So this is the formula you use to find the distance between any two given coordinates, any two given points, right? Now, you can ask me, can I write x1 minus x2 whole square and y1 minus y2 whole square? Yes, you can write this as well. What matters is the difference between both the x coordinate and the difference between both the y coordinates. And then you're going to square both those values, sum them up, and take a root of that value, right? Great. Now, the other thing is, if you are doing, let's say, x1 minus x2, for the y coordinate, you should also do y1 minus y2. You cannot do y2 minus y1 and then say x1 minus x2. So in that case, yes, it's going to be a mistake. Okay, so let's use this idea, this formula, to solve one of the questions, which is, we are going to use this formula. So the question says, the distance between 2 points P, which is 7 and 8, and Q, a plus 1 and 9, is 15. So they've given you the distance between 2 points P and Q. P and Q, they're given the distance. So what are they asking for? Find the value or values of A. Notice in the coordinate for both P and Q, there is a constant A. And they're asking you, using this formula, make A the subject and find the possible values of A. How do you do that? Use the formula directly. So you're going to find out the distance between both of those points. So you're going to say the distance between PQ is going to be given by root over my x1 minus x2. So I'm considering this to be my x1. That is a plus 1 minus x2. That is 7 whole square plus my y1 minus y2. So it's going to be 9 minus a whole square. Now what are you going to do? You're going to equate this to the value 15. Why? Because they're giving you the answer. I mean, the value for distance. So they've given you that the distance between both the points is going to be 15, right? 15 units. So how do you work with this equation now? How do you make A the subject? Very simple. What you have to do is you're going to square both sides to remove the root over. Great. Now find the square of 15. That is going to be 225. A plus 1. You can directly diagonalize 6. Great. Now what do? You're going to open the bracket. That is, you're going to carry out simplification. And you're going to find the answer as 225 is going to be a square minus 12a plus 36 plus 81 minus 18a plus a square. Well, now just make 0 the subject. You'll get a quadratic equation, I suppose, yet. So it's going to be a square minus 15a minus 54. Now, this is why in the question they had said find the values of a. So basically, there are two possible values of a for which the distance between PQ is going to be 50. Now you may ask, how are there two possible values of A? For example, let me give you this simple example. Let's say this is P and this is Q, right? So this is one possible position for P and Q to have a distance of, let's say, 15 units. Now Q can also be, let's say, on this side, right? Q can also be on this side exactly opposite and still have the same distance 15. Or Q can be at this, in this position over here and still have a distance between them as 15 units. So there are actually more than one possible way to still get the same distance of 15 units, which is why you're getting two possible outcomes for A such that the distance between P and Q is going to be 15 units, right? So when you solve this quadratic equation, these are going to be your answers. Fair enough. So we found out how to use our first formula, that is the length equation, right? So that is out of the way. Now the second equation we're going to work with is the gradient. Now the gradient is a simple formula. You probably already know it. It is saying that between any 2 points, again, P and Q, x1, y1 and x2, y2, right? So how do we find the gradient? The rise over run, right? So the difference in rise divided by difference in run, and that is going to be your gradient. So you're going to write it as y2 minus y1 divided by x2 minus x1. Find position minus your initial position, or you can write it as initial position minus final position. That is to say y1 minus y2 divided by x1 minus x2, whichever you're comfortable with. Doesn't matter. The last thing is finding the midpoint. And how do you do that? Let's say again we have the case of P and Q. In that case, you're basically going to take the half of the sum of both coordinates. What do I mean by that? Let's say again, let me give you a bunch of values. So let's say this is P and Q. Right. In this example, how do you find the midpoint? You're going to take the sum of both x coordinate divided by 2. Sum of both y coordinate divided by 2. Right? That's how we're going to get the midpoint. So over here, 2 plus 3 divided by 2. Again, 4 plus 9 divided by 2 to get the mid y coordinate. 4 plus 9 divided by 2. Now I'm going to get a bunch of odd numbers, sorry, fractions, and it's going to be 13 by 2. Right? So 7.5 and 2.5. Sorry, 6.5 and 2.5. So in this case, we have the midpoint between two given coordinates, that is P and Q. So this is how you're going to work with gradient, midpoint, and the length formula. Now, talking about gradients, the next thing you need to understand is the idea of having parallel lines and collinear line. So let's say not collinear line, but collinear points. Anyways, so let's say you have these two lines. I mean, I do have the example. So these two lines, let's say x and y, these two lines. Now, since they have the same gradient, let's say the gradient is equals to 1. Again, the gradient is equals to 1. What does this mean? This means that both these lines are never going to interact with another. That is, they're never going to collide or intersect at any given point. Now, is this possible for any other set of gradient? No, it is not possible. Granted, both the gradients are different. So let's say one is 1, the other is m is equals to 0.9999. Doesn't matter. If both the gradients are different, they are going to intersect at one given point for sure. So your gradient, both the gradients need to be exactly same for them to be parallel, right? That's a basic concept. Now the other concept is having collinear point. What does that mean? Let's say I have one line, call it line AB, Now I also have another point, which is C. Now these 3 points are going to be called collinear. What does that mean? All these 3 points are going to be lying on the same line. So they are called collinear, on the same exact line. So how do you find out that these 3 points are collinear? You're going to notice that the gradient between AC is the exact same as the gradient between CB. So over here, when finding the gradient between CB, you're also going to see that the gradient is 1. In the gradient between AC is 1, the gradient between CB is also going to be 1. So now let's use this idea of the gradient for collinear points to solve a question. What is the question? This one, right? It's saying the coordinates of 3 points are A, 8 minus k and 2, B, minus 2 and k, C, minus 8 and 2k. Find the possible values of k if A, B, C are collinear. So A, B, C. Since they've mentioned the coordinates in this order, we are also going to write or draw our diagram in the same order just to make it easier for us to understand. So if A, B, C are collinear, then they lie on the same line. Okay, that is the answer. Right. So we can answer it for ourselves. Now, granted, both all of these 3 points are collinear, meaning they lie on the same point. The gradient between AB and the gradient between BC is supposed to be exactly the same. Can I take any other pair of coordinates? Yes, I can. If I take AB and AC, shouldn't it also be same? Yes, it should be same. Because the gradient between A and B should be, let's say, I don't know, I'm taking an arbitrary value of M being 0.5. Right? So if the gradient between AB is 0.5, the gradient between AC is also supposed to be 0.5 because it is the same exact time, right? Fair enough. So if I show you the solution that is already given, notice the gradient between AB, how do you find that out? You're basically going to take the rise over run. So it's going to be, which one is A and B? Wait, this one and this one. So it's going to be K minus 2 divided by minus 2 minus 8 minus K, right? This is going to be equals to B and C. So B and C. So take 2K minus K divided by minus 8 plus 2, right? So when you open the brackets and you're going to get up till this. Now what do? You're going to use cross multiplication and you're going to get ultimately a quadratic equation when you simplify everything. Now, fairly simple up till that point. Now what do? You're going to either use the quadratic formula or factorize on your own, and you're going to see that there are two solutions. That is, k is either 6 or k is equals to minus 2. Therefore, there are two values of k such that these 3 points make a collinear line, right? That is, there are two such values of k for which all the 3 points are going to lie on the same exact line, right? You can also use a graphing calculator or plug in both the values of k to find what the shape of both of these lines are going to be, right? Fair enough. So these are the 2 points. You can try and answer it for yourself as well. Now, what else? The next thing you need to understand is the idea of perpendicular lines. Now, there is an interesting formula for perpendicular lines as well. Now, in case of parallel lines, we saw that gradient is same if the lines are parallel. When the lines are exactly perpendicular to each other, that is 90 degrees are being made. Let's call this line A, let's call this line B. In that case, the product of both the gradient M1 and M2, let's have this as M1, let's have this as M2. The product of both the gradients are supposed to be minus 1. That is, if I have line AB and the gradient of this line, let's say, is minus half, what is the gradient of the perpendicular line to AB is going to be? So if I have a perpendicular line this, call this CD. What is the gradient of CD going to be? It is going to be the negative reciprocal of the gradient of AB. What does negative reciprocal mean? So if I have minus half, it is going to be negative of minus half, that is positive half, and the reciprocal of half, that is you're going to turn this value, the denominator on numerator, numerator on denominator. So the reciprocal value is going to be 2. So negative reciprocal, meaning it's going to turn positive and then it's going to be the reciprocal value, or either way around. So let's say I have positive half. What is the negative of half? It's going to be minus half. What is the reciprocal? It is going to be 2. So minus 2. So this is how you can directly find the gradient of the perpendicular line. Or you can plug it in the formula, that is m1 times m2 is going to be minus 1. So let's say again, if m1 is half, you don't know m2, but you know the product of both the gradients should be minus 1. So naturally, your m2, if you make it the subject, is going to be minus 2 because of take it 2 to the other side. So this is exactly what we found out when we directly applied the notion of negative reciprocal. So if you have line AB, which has a gradient of, let's say, minus 3, you want to find the gradient of perpendicular bisector or the perpendicular line, the gradient of the perpendicular line is going to be the negative reciprocal. So if the gradient was minus 3, the perpendicular will have a gradient of positive 1 by 3. So take a bunch of examples and see if you can, easily in your head find the gradient of the gradient of the perpendicular line. Now we can use this idea to solve a few questions. For example, in this one, the vertices of triangle ABC, A minus 4, 2, B 5 minus 5, and C K plus 2. Find the possible values of K if angle ACB is 90 degrees. Therefore, they're telling you between point A and C, if you draw a line, AC, and then again between C and B, if you draw a line, this should be a 90 degrees. That is, when you connect all the dots, it's going to be a right angled triangle. So over here, you know that the gradient between CB, M, should be the negative reciprocal of the gradient of AC. Now notice they're asking you to find out the unknown K. And where is the unknown given? It is as the coordinate of C, right? Fair enough. So to find that, I already know or can figure out the gradient of AC and gradient of CB. Now from the formula note, the gradient, the product of both the gradient, that is if both of them are right angle to each other, then it is going to be equal to minus 1, right? Fair enough. So I can find out the gradient between AC times gradient of CB and say it is going to be equal to minus 1. Now how to find the gradient of AC? Let's see. It's going to be y1 minus y2 divided by x1 minus x2. What are they considering y1? They are considering to be the y coordinate of C, minus 2. Fair enough. Then x1 minus x2, that is k minus 4. Fair enough. Times k plus 2 minus 5. Again k minus 5. Fair enough. So this is your gradient for AC, and this is your gradient for CB, right? Okay. So when you find the product between both the gradient, it should be equal to minus 1. Now, what is the unknown variable over here? 1. Sorry, I mean k. So there is one unknown variable and there is one equation. So we can directly solve for k and find an answer to this, right? So when you simplify everything, open the brackets and carry out simplification, you will end up with a quadratic equation. And we know how to solve these quadratic equations. Either you use the quadratic formula, or you're going to carry out middle term break. It is always good to show uh, another step in between these two steps where you're showing the middle term break process. Or sometimes it's okay, some teachers don't cut marks for directly showing the factors if you do it mentally, but I always prefer showing either a third step over here or showing the use of the quadratic formula. Fair enough. Now, when you solve for k, you see that k is either -5 or 2, right? So, what did we see over here? We use the notion of perpendicular line, that is the formula for gradients in case of perpendicular lines. And we found both the gradient, found the product, and equated that to -1. And then when we solve for the unknown value, we saw that we get a quadratic equation. And then when you factorize it, you get two solutions, right? This is how you can solve questions related to gradient of perpendicular lines. Great. Now, the next thing we learn about is the straight line equation. Now, this is a fairly simple equation. You probably have studied it in Gen Maths or previous years in probably grade 8, right? And for this, there are two main formulas. What are they? They are y is equals to mx plus c, this one, where m is of course your gradient and c is what? The y-intercept. Now, let's say you have a line, right? You have a line, and these two, consider these a and b to be your coordinates. Now, what is this point going to be? This is going to be your good old y-intercept, right? So basically, when x is equals to 0, x is equal to 0, the y-axis, whenever the line cuts the y-axis, that is the y-intercept. Whenever the line cuts, if you extend this line, right? So this is going to be what? Your x-intercept, right? That is going to be your x-intercept, wherever the line is going to cut the x-axis. Great. Now, since this is your y-intercept, this is going to take the value of c. So you can often find out graphically what the value of c is going to be in a linear equation, right? You just find out whatever the y-intercept is, and that you can directly say is the c value. Great. That is one thing done. The other thing is, of course, gradient. We know how to work with gradients. You're going to find, again, y1 minus y2 divided by x1 minus x2, right? So let's say you know the coordinate of a and b. You can find out the gradient between a and b. You can find out the gradient between a and b, and also identify the y-intercept and directly form an equation. So what did we do? From a graph, we read the y-intercept, plugged in over here as c. We took any 2 points a and b, found the gradient, and plugged in place of m, right? So you directly get, in the case that you have a graph, you directly get the equation for a straight line. Now, of course, you're not going to always have a graph. What do you do in those cases? Very simple. You're going to take the help of the second equation. That is, when you have only two coordinates available to you. You don't know the y-intercept, you can't read it, but you only know the coordinates of a and b. So in this case, notice what are you going to do? You're going to use this formula. That is, let me decrease the size of this. You're basically going to say that y minus, take any coordinate b or a, any is fine, any coordinate that lies on the line is going to take the place of y1 and x1, right? So take any coordinate, doesn't matter, a or b, and plug in the y coordinate of it. So in this case, it's going to be y1. So y1 is equals to whatever gradient you found out between a and b. So basically, y2 minus y1 divided by x2 minus x1. Whatever you get over here, plug in over here, right? Fair enough. Now then, again, keep the x as it is and plug in the x coordinate of whatever point you took. If you took a, plug in the x coordinate of a. So what did we do? We plugged in the y coordinate. We plugged in the gradient between a and b. And we plugged in the x coordinate of whichever point we picked. Great. That is all we did. And when you simplify this equation, you're going to get an equation that is going to look like your first equation. Your what? First equation. When you carry out simplification of this, it is going to look like your first equation. Great. So we can try and solve a question related to this formula. Let's see what we have. Find the equation of the perpendicular bisector of the line joining A and B. Okay, so they've given you a bit of information. That is, they've given you what the coordinates for A and B is going to be. A is going to be positive 3 and 2. So let's say this is let's say x1 and y1 in this case is going to be what did they say? 3 and 2. Okay, so this is going to now be 3 and 2. What did they say about B? It's going to be 7 and 10. Fair enough. 7 and 10. Great. So we know, what do we know? We know the two coordinates of two separate points. And we're asked to find the perpendicular bisector of these 2 points. That is, when you have these 2 points and form a line that passes through both A and B, what is the perpendicular bisector of AB going to be? So, the first thing you do in this case is, of course, find the midpoint of AB. Find what? The midpoint of AB. How do you do that? Very simple. We've learned about this. So, midpoint of AB is going to be 3 plus 7 divided by 2 and 2 plus 10 divided by 2. So, 5 and 6. Is it 5 and 6? Let's see. Yeah. So, the midpoint of AB is 5 and 6. So, the perpendicular bisector, that is the line that is going to pass through the midpoint of AB. What is it going to do? It's going to pass through the midpoint of A and B. Perpendicular bisector. Bisector basically means if you have these 2 points, it's going to bisect through these 2 points A and B. Bisect, meaning equally halve the point. Having is equal. I mean, equally cut through the space. So if you have, let's say, a larger distance, AB, it's going to equally cut through the distance, right? The line is going to be equally away from A as compared to B. That means it is it is bisecting through A and B, right? Now, when you add perpendicular bisector, you're just telling the student that it is going to be 90 degrees compared to the line through A and B. So, perpendicularly, it's bisecting AB, meaning it is going to have the distance and it is going to make a 90 degrees between A and B. So, the line between A and B is going to be perpendicularly bisecting. Fair enough. Now, so you found out the midpoint, that is going to be 5 and 6. So, let's note that down. 5 and 6. Now, they're also asking you to find out the total equation of this line, right? What is the entire equation of this linear line? Fair enough. So how do we find it out? We know the coordinate, right? We know the coordinate. Now we need to find out the gradient of the line. How do we find out the gradient of the line? We need to use the idea of perpendicular line equation. What is it? It says that the gradient between AB, if you multiply that with the gradient of the perpendicular line, it is going to give you -1. So I can say that the gradient of the perpendicular line is going to be the negative reciprocal of AB. Of what? AB. So let's find out the gradient of AB. So m of AB is going to be what? They've already done this, so let's look at that. So gradient of AB is going to be 10 minus 2, 10 minus 2 divided by 7 minus 3, 7 minus 3. Fair enough. So what is the gradient? The gradient is 2. But this is the gradient of line passing through AB, not the perpendicular bisector. So what is the gradient of perpendicular bisector? The negative reciprocal. So it's going to be negative half. Reciprocal, which is half, negative means minus half. Fairly simple. So now we know two things. One of the coordinate that lies on the line. So one of the point that lies on the line, the midpoint, and we also know the gradient of the line. Can we now take the help of second equation and form the equation of the line? So we can do that. And how do we do it? Let's see. Y minus y coordinate of the point that we are going to take, that is the midpoint, and it's going to be in our case 6. Y minus 6 is equals to, what is the gradient? Minus half. X minus x coordinate of the point, that is 5, and it's going to be 5. Now can we simplify this? Yes, we can. Y is equals to minus half x, positive 5 by 2, plus 6. Now when you simplify this, it's probably going to be minus half x to 12, 17 by 2. Fair enough. So you can also further simplify this and take both the 2 to the other side and say it's going to be 2y minus x plus 17. This is how they kept the final answer. Oh, sorry, they took the x to the other side. So 2y plus x is equals to 17. So there are several ways, if you note the red annotation, there are several ways to keep your answer. You can keep it as this, you can keep it as this, you can keep it as this. All of those are accurate. All of those are accurate. However, it may seem a bit more, I don't know, simple to remove the denominator and keep all of it in whole numbers. So you will often see the answers in the book, at least, written in this form, right? But again, all of these three forms are accurate, right? Okay. So this is how you solve your straight line equation questions. Next, we will move on to the next topic, which is probably finding the area. Okay, so the next thing we talk about is finding the area for rectilinear figures. What does this mean? Basically, any sort of shape that is made out of straight lines. So if you have, let's say, this weird shape, right? I don't know what this is, but consider it to be a shape consisting of 5 straight lines, right? The 1, 2, 3, 4, 5, right? So this is a shape with 5 straight lines. So this is what? A rectilinear figure. It's made out of straight lines. It can also be a triangle, it can be a rectangle, it can be literally any shape, but it needs to be made out of straight lines. So in those cases, when you have any sort of shape made out of straight lines, if you know the coordinates of all the points on that shape, so A, C, B, or the weird shape that I drew, for example, this one, if you know the coordinates of this point, this point, this point, and this point, all 5 points, you can use a very interesting formula to find the area of that shape. To find what? The area of the shape. What is the formula? It's called the shoestring method or the shoelace method. Now, when I read your book, I saw that it's not as relevant to your syllabus anymore. But when we studied, we did have it in our syllabus and we did have questions relating to it. I don't know if you're going to have questions related to this, but I thought why not just include it. So, what does the formula say? The formula is basically half times, by the way, I'm taking the example of what? A triangle. This one. I'm taking this example to teach you. So, let's see. I'm trying to find the area of a random triangle, and I also know the coordinate A, B, and C. So all 3 points, I know the coordinate. Now what do? The formula says half times modulus of, why the modulus? I'll explain later. So half times modulus of x1, y1. So you're going to vertically write this, and it's going to be very important later on. So vertically write the first coordinate, vertically write the second coordinate, vertically write the third coordinate, and vertically write again the first coordinate, right? So you're again going to write your first coordinate at the end. So you start with one coordinate, you roam around and come back to the same coordinate. So if you have 3 coordinates, you're going to have 4 separate coordinates written on it, where the first coordinate is only repeated. Fair enough. So now, how do you write this coordinate in sequence? So go either clockwise or anti-clockwise, right? So what you're going to do is, let's say A, then C, then B, then again A, right? So if you're starting from C, go with C, B, A, again C. So that's how you're going to write the coordinates in sequence. Again, if you write from what did I say? From B, then A, then C, then again B. Alright, so that's how you're going to find the sequence of writing the coordinates. So we know how to construct this formula. Start with literally any coordinate and go in sequence, so one after another, right? So take the adjacent one, then again the adjacent one, then again the adjacent one. Fair enough. So if you decide clockwise, go clockwise. If you decide anti-clockwise, go anti-clockwise. Doesn't matter. So now you're writing 4 pairs of value over here. Now, after that comes the real part, the interesting part. What are you going to do after you write this beautiful formula? You're going to multiply, notice, you're going to multiply x1 with y2, multiply x2 with y3, multiply x3 times y1. So you're basically drawing a downward right arrow. So from x1, downward right arrow, from x2, downward right arrow, from x3, downward right arrow. Now, after finding the product of all these pairs of value, you're going to add them up. So these 3, add them up, right? x1 times y2 plus x2 times y3 plus x3 times y1. Fair enough? Great. Next, what you're going to do is y1 times x2, y1 times x2, y2 times x3, and y3 times x1. So you're now drawing an upward right arrow. Upward right arrow. So you are now going to subtract these values. So you're going to say minus x2 times y1 minus x3 times y2 minus x1 times y3, right? So what you have done is first added all the values which were downward right arrows. Then you're subtracting all the values which were upward right arrows. Fair enough. Notice, all of this operation is happening inside the modulus function. Now, what is the purpose of the modulus function? The point is the area is never negative, right? Whatever value you get over here may be positive or negative, depending on either you're going clockwise or anti-clockwise. Based on that, your value inside will be either negative or positive. So to omit that, you have the modulus function, because area is of course a scalar value. So it's never going to be negative. Hence the modulus function, right? Now, when you simplify everything, you're going to halve that value. And the final answer that you get after halving the entire sum, it's going to be the area of the rectilinear shape. In this case, it was simple because you have only 3 coordinates, so 4 pairs of value and this much of an operation. So let's take an example to better understand how to find the area. So take a note, this is how your formula for the area is going to be. I know this is quite lengthy and tedious, so I guess it's not in your syllabus because it was written in the book that it's not relevant to your syllabus anymore, but it's just a good thing to know. Anyways, so taking the example of this question, which one? This one. So we have to find the area of ABC, triangle ABC. How do we find it out? We know the coordinates of A. It is 1. Let me take another color. It's going to be 1, 3. B is going to be 9, and I suppose 2. It is 1, 3, right? Yeah. And this is going to be 9, 2. And this, my friend, is going to be, what is this? This is 2 or 3. This is 3. Yeah. 3, and this is 8. Fair enough. So these 3 coordinates, so they have started from A. So write the coordinate for A, then take either C or B, depending whether you're going clockwise or anti-clockwise. So in this case, they've taken 9. Oh, this is 9, 1. Sorry. This is 9, 1. Okay. So now they have taken the adjacent coordinate, which is B. So 9, 1. Next one is going to be C, which is going to be 3, 8. And next one, again, the starting coordinate, which is 1, 3. All of which is going to be inside your modulus function. Now, what are you going to do? Downward arrow, downward arrow, downward arrow. Fair enough. Next one, upward arrow, upward arrow, upward arrow. Great. So half times 1 plus 9 times 8, whatever that is, plus 3 times 3, right? Minus 9 times 3, minus 3 times 1, and again minus 8 times 1. Now, if you calculate all of this, it's going to be, let's check by the way with the book answer. It's going to be 1, 1, 9 times 8, 9 times 8, 3 times 3, 3 times 3, minus 3 times 9, yep, minus 1 times 3, yep, minus 8 times 1. Fair enough. So we are correct. Now, when you simplify all of this, whatever value you get, which is going to be at 44, I guess. So half times modulus of 44, and when you have this value, it's going to be 22. So the area of this rectilinear figure, which is a triangle, is going to be 22 unit square across. Now, if in your I don't know, answer space they have not given you any sort of place to write the unit, it's better to just write unit square. Or if they've let you know it's meters, meter square, whatever it is, it's better to give the units. You don't want to, lose unnecessary marks. So anyways, that's how you find out. The area of any sort of shape made out of straight lines. Now, the next thing that we will be talking about is converting nonlinear functions into linear functions. Basically, when you have a straight line, such as this one, this is a linear function. Typically speaking, y is equals to mx plus c. your linear function or straight line function. Now, whenever you have um, any other sort of graph usually, which is going to result in a curve, be it e to the power x, or let's say log function of x, ln function of x, or let's say x to the power 2, 3, 4, anything. These are all going to be non-linear function because it is going to result in some sort of curve, right? Okay, so these are your non-linear functions. Now, what do I mean by converting non-linear equations to linear equation? What I basically mean is I'm talking about a specific type of equation, that is an exponential equation, where you have e as a part of the function. Basically, I'm talking about e to the power x equations. Now, in these cases, when you have e to the power x graphs or equation, you can convert this into a linear function. How do you do that? You have to use the ideas from chapter 5, which is logarithm. You have to use the idea of logarithm and ln function to convert e to the power x curves into straight line equations, right? Now, we're going to try and see how we can convert an exponential equation or e to the power x curve into a straight line equation. So I'm converting a non-linear equation, which is e to the power of x, to a linear function, which is typically going to be y is equals to mx plus c. Knowing that, let's give it a shot. Again, I'm going to use ideas from chapter 5 or logarithm. So you need a good basis from logarithm. Okay, so fair enough. Convert y is equals to a e to the power minus bx, where a and b are constants. Fair enough. Into the form of a straight line equation, which is y is equals to mx plus c. Great. Now, to solve this, what am I going to do? Notice one thing. Whenever working with e or exponential functions, you're going to use instantly ln function. You're going to use what? Ln function. Ln. Now, what is ln, by the way? Just to clarify, if you already don't know. Ln is nothing but log base of e, right? So if you have ln of x, it basically means log base e of x, right? So what does it mean to have a log base of e? Basically, it is asking you what power of e does it need to have to give x, to result in x. So if I have log base e of 2, what power does e need to have to give 2 or to result in a value of 2? So if you use a calculator, what are you going to get? Let's see. If I have ln of 2, what I'm going to get is 0.6931, right? So this is my power of e that I need to result in a value of 2. Can you check that? Yes, we can. Let's say e to the power of whatever answer we got, ln 2, it is going to result in what? 2. So e to the power of 0.6931 is nothing but 2 again. So basically log base e or ln of 2 or ln of 2, log base e2 is nothing but ln of 2. It's telling you what power does e need to have to result in a value which is 2, right? If that is clear, that is basically a refresher from chapter 5. If that is clear, we can work with the equation. Now, how do we break this equation? We know we need to work with logarithms. We know we need to work with ln function. So in this case, I need to introduce ln term on either side of the equation. What does that mean? I'm going to write it as ln of e. What am I going to do? Ln of ln of e on this side, so ln of y on this side, and ln of the entire term on the right hand side. So on the left hand side, I'm taking the entire term and saying ln y. On the right hand side, I'm saying taking the entire term and saying ln of a times e to the power minus bx. Now, one thing to remember is a basic thing. Whenever you're manipulating any sort of equation, let's say you're adding some sort of term to the equation. Let's say you have y is equals to 3x and you want to divide by 3. Not that it's going to help you by any means, but let's say you want to, for some reason, divide by 3. You have to do that on either sides of the equation. So y divided by 3 over here and 3x divided by 3 over here, resulting in y divided by 3 and x. So whenever you're adding, subtracting, multiplying, dividing, introducing any sort of term, you have to do it on either sides of the equation, right? Kind of. So if you know that, we can move on. We now need to use an identity from logarithm, a formula rather from logarithm, which says log of AB can be written as log A plus log B. So it's basically telling you that whenever you have two terms multiplied inside of a logarithm function, you can break it down into two individual logarithm. Okay, so what does this basically mean? So if I write this in terms of ln function, this basically means whenever you have the same base, over here what's the base? E. Over here what's the base? E, right? So in either cases, notice the term may be different. The term may be different. In one it is A, in the other it is B, but the base is same. The what is same? Base. In both cases, the base is E. Hence, I can apply this formula to say that if I have ln of A plus ln of B, I can go and say this ln of AB. To further give a simpler example, I'm going to say ln of, let's say, 36 can be written as ln of 12 plus ln of 3. Can I write this? Of course I can, because ln of 36 is nothing but 3 times 12, right? Hence I can consider 3 to be my A and 12 to be my B. Fair enough. So I am basically breaking down the term, breaking down this value into two terms, and then doing what? Dividing into two different ln function. This is to say that I can always, if I have two terms inside a logarithm, I can break it down into two different terms. So if you have log A times B, I can say log A plus log B. If I have log A plus log B, I can multiply the terms inside and say log A times B. Very simple. So in this case, what are the two terms going to be? What are the two terms going to be? It's going to be ln of A plus ln of E to the power of minus bx. Now, here I'm going to apply another formula or identity from logarithm. That is, whenever, let's say you have log base 10 of 2 to the power of x and log base 10 of x to the power of 2. So in all of these cases, I can apply a simple formula. That is, whenever you have, let's say, any sort of power to your term, I can introduce or bring that power in front of the log function, in front of the log function, right? Okay, so I'm basically going to write x times log of 2, right? So I can also write 2 times log of x. Can I write this? Yes, I can. So in both cases, what am I doing? I'm bringing the power in front of the log function.
Great. So let's apply this to our main equation. What is going to happen? It's going to be ln of y is equals to ln of a plus, sorry, minus bx ln of e. So what did I do? Notice I brought this entire power in front of the ln function. Hence, due to plus and minus results in a minus. Clear? Fair enough. Now, after this, what do we do? Let me give you an interesting piece of information. Whenever you have ln of e, it is going to be exactly 1. Why is that the case? Remember what I told about having a ln function? A ln function is nothing but log base e of e. So notice that what power of e do I need to bring the same value as e? It's going to be as simple as 1. If you have e to the power 1, it's going to give you the same term as e itself, right? So granted, you know that, you can easily say ln of e is nothing but 1 itself, right? Great. So I can cancel this term and say it's nothing but 1. So you've already received the main equation, linear equation, which is to say ln of y is minus bx plus ln a. Now, can you relate to the y is equals to mx plus c equation? You should, because y is equals to mx plus c is nothing but related to ln y minus b and ln a. So you can simplify this or directly say my gradient is going to be minus b and my y-intercept is going to be ln a, or the c value is going to be ln a. So what have I done over here? I have simply converted a nonlinear equation, which is an exponential equation, into a linear function where this is my y, this is my mx, and this is my c. So this has taken the form of y is equals to mx plus c. And we know typically y is equals to mx plus c is nothing but a linear equation, right? So this is how you convert non-linear equations into linear equations. Very simple. Now, I should be now able to apply this formula or this logic to different sums where they will often ask you or give you data points to correlate and get back to the initial either linear equation or non-linear equation. So let's now use the same concept to solve a similar sum. Now in this case, the question is saying variables x and y are such that y is equals to a times b to the power x. Notice one thing. Previously, we worked with e to the power of minus bx. How is it different? Over here, you're not using e, which means you're not going to introduce a ln term over here. You're still going to use logarithm, but you're basically going to bring a log base 10, a log base 10 over here. Or actually, for that matter, it can be log base anything, but log base 10 or LG is sort of the norm to use to keep it simple, right? Fair enough. So over here, I'm going to use logarithm, the same method, but not ln function. Why? Because we don't have um, an exponential term over here, right? So I'm going to use what? Log. Fair enough. What is it saying? This is the equation, and they're saying a and b are constants. Great. The diagram shows the graph of log y against x passing through the points 2, 5 and 6, 3. Notice one thing. Over here in the equation, do you see log over here? No, you don't. So what do you have to do? You definitely have to go through a process of making this non-linear function a linear function, such that such that you get this straight line. And notice over here, what are the variables? Log y and x. So immediately from the graph, you have to introduce what? Log to the equation. Log base what? 10. So over here, you can't just introduce any other log base to the equation. It can't be any other value other than 10. Why? Because LG basically means log base 10. So you have to introduce a log base 10 into the equation to linearize the formula. Great. So you have to linearize this formula, this expression, and bring a log into the same equation. So now how do you do this? Very simple. You're going to take log y over here, log a times b to the power x. And what did I tell about breaking the terms out? If you have the same base, you can break the two terms apart. Great. So LGY is going to be LGA plus LGB to the power x. And what did I talk about? What did I tell about bringing the power in front of the logarithm? Whenever your term inside has a power, you can bring that directly in front of the logarithm sign, right? So if you have log y over here, you can say log a plus x LGB, right? Great. Now what can you do? You can reorganize this equation to make it more suitable for you. LGB x plus LGA, right? Fair enough. Now can you relate this to your typical line formula, which is y is equals to nx? It turns out you can. So LGY is your y expression, and LGB is nothing but your gradient. Log of b is nothing but your gradient, and LGA is nothing but your y-intercept. This is what you find out. Now, in your graph that they've given you, the line that they've given you, notice LGY is plotted against what? LGY is plotted against what? X. X. So they have given you the line for this exact expression. Hence, how do you find out the values of A and B? Sorry, A and B over here. I have linearized the formula. And I know LGB is the gradient and LGA is the y-intercept. But how do I find the values? How do I find the constants of A and B? Right? To do that, very simple. They've given you most of the information. What you have to do is use these 2 points to find what? The gradient. Because notice, when you relate it with the y is equals to mx plus c equation, LGB log of b is nothing but your gradient of the line. Gradient of which line? The line where LGY is plotted against x. The line where LGY is plotted against x. So whatever the gradient of this line is, should be equal to log of b. Should be what? Equal to log of b. Now take your time and soak it in, right? While you do that, I'm going to find the gradient. Okay, so they've already found out the gradient, which is 2, right? 2 is the gradient of the line. 2 is the gradient of the line. Now the question is, I understand LGB is equals to 2, or for that matter, LGB is equals to the gradient, which is 2. How do I find out the value of b? If you know how to work with logarithm, you know the answer to this already. It's basically that LG is nothing but log base 10, right? So if I simplify, I can say by taking 10 to the other side, b is going to be 10 to the power of 2, right? If you already know how to work with logarithm, this shouldn't be an issue, okay? So I know the answer to be 10 to the power 2, which is going to be, of course, 100, right? Great. So I know my b is going to be what? 10 square or 100. So to find log of a, I'm going to take the help of the graph and the data given to us. Notice one thing. I know for two specific points the value of x and log y. Again, x and log y. I can choose any of these points and help myself find log of a or the y-intercept. So let's take 2 and 5, 2 and 5 as our coordinate. Now, how are we going to substitute this and where are we going to substitute this? Very simple. If you even go to the main formula that we just linearized, right? That we just linearized right now, this one, notice. Do you know the value of log y for any one coordinate? Yes, you do. What is it? 5. It's going to be what? 5. Do you know the gradient of this equation? Log b. Do you know the value of log b? Yes, you do. What is it? 2. Why? The gradient of this equation of this line is nothing but log b. We just figured that out, right? So you know the value of log b, which is going to be 2. Do you know the x coordinate of this point? Yes, you do. What is it? 2. What is it? 2. So you know the x coordinate. Great. And log of a is something that you're going to make the subject and find the value of. So let's do that. I know log y to be 5. I know log b to be 2 times x, which is again 2. And that is going to be added to log a. Let's make log a the subject. And what we find is the answer is going to be 1. But you still need to make a the subject over here. You need to put 10 to the other side. That is to say, a is going to be equal to 10 to the power of 1. Again, remember, LG is nothing but log base 10, right? And whenever we work with logarithms, as such as this one, for example, log 10 is equals to 9. How do you work with this one? Sorry, it's supposed to have a term inside. Let's say it's a or a, pretty much anything. So how do you make a the subject over here and find the value of a? It's going to be a is equals to 10 to the power of 9, right? So that's some value if you expand it. I don't remember. Is it, how much is it? I guess it's a billion. Yeah, 1 billion. So anyways, point is, if you have, let's say, log base 9 of b, that is equals to 8, how do you make 8 the subject? It's going to be, b is going to be 9 to the power of 8, whatever the value is, right? That's the point. So that is how you make the term inside a logarithm the subject, right? Great. So if you know that, you have found out yourself the value of the constant a. And previously you found out the value of constant b. And that is how you solve this question. It's fairly easy. Whenever you come across these questions, the first thing you're going to do is whenever you have such an equation, you're going to linearize it. You're going to do what? You're going to linearize it. This nonlinear equation, you're going to convert into a linear equation, right? Then what do you do? You're going to compare that equation. Which equation? This equation that you just broke down. You're going to compare that with what? The usual linear equation formula, which is y is equals to mx plus c. And by the help of the data given, you're going to find the value of the unknown, the constants usually. So that is how you solve this one. I'm going to now solve several few questions quite fast. So keep up with me. All right. So the next question says, when log y is plotted against x, a straight line graph passing through points 2.2, 3.6 and 3.4, 6 is obtained. Given that y is equals to a times b to the power of x, find the value of constants a and b. Again, a similar type of question where they are asking you to find the constants a and b. Now, how do you do these type of questions? You're going to break it down using logarithms. Now, over here, do you see e anywhere? No, you don't see an exponential value over here. You don't see the use of e. Plus, they've also given you this bit of information that a graph of log y has been plotted against x. So you're not going to bring ln into this equation. What are you going to bring? You're going to bring LG, log base of 10. Because they've already given you this bit of information where they're using LG of y. They're using what? LG of y. Log base 10. Hence, you're going to bring log base of 10 into your main equation. Fair enough. Now, the 2 points that they've already given are 2.2 and 3.6. So 2.2 and 3.6 over here. 2.2, 3.6. Second point is 3.4 and 6, 3.4. And it's going to be 6 somewhere up there. 3.4 and 6. So this is your log y value. Sorry, that is your x value. That is your x value. This is your log y value. And this is your log y value. Right? Okay. Now, what are they asking you to find? The constants. So to find the constant, I have to linearize. I have to do what? I have to linearize this equation. I have to make this an equation that is similar to y is equals to mx plus c. Why? Because to find the gradient, I have to use these 2 points, which is a part of a straight line, right? Which is a part of a straight line. I need to use these 2 points to find the gradient. How? Rise, divide by run, right? So I'm going to use that formula to find the gradient. However, this is not a linear formula. I have to convert this into a linear formula so that I can compare the main equation with our y is equals to mx plus c. So let's try and linearize it by bringing in log base 10 to either sides of the equation. So how is it going to be? Let's try it out. So if I move this around, it's going to be log of y log a b to the power of x. Now, I can also break the terms apart by writing it as log a plus log b to the power of x. Now, what did I tell about bringing the x in front of the logarithm? Whenever you have a power, you can bring the x in front of the logarithm sign. Fair enough. Let's do that. It's going to be log y is equals to log of a plus x log b. What is the equation? This one. Log y is equals to log b x plus log a. Is that exactly the same? We can just rearrange it to make it exactly the same. It's going to be log b x plus log a. Now, mind you, the method that they have taken over here is a bit different. They've plugged in the 2 coordinates over here. The 2 coordinates over here. Notice, if you follow the circled parts, those are the 2 different coordinates. And they've plugged in both the coordinates into this equation that we have just now derived. Why? Because they want to simultaneously solve the equations and find values for log b and log a. Right? So, if they do that, if they find the values of log b, they can then, let's say the value of log b is 10. So they can then find the value of the constant b directly by saying b is equals to 10 to the power of 10. Let's say the value of log a is 7. So what is a going to be? A is going to be 10 to the power of 7. So they're basically using simultaneous equations to solve this question, which is again something you can do as well. But I'm going to stick with the previous method that we have tried, that is finding the gradient from the given points, right? And comparing with our y is equals to mx plus c. So if we try that, it's basically going to be to find the gradient, m is going to be 6 minus 3.6 divided by 3.4 minus 2.2. Let's find the value. The gradient is going to be 6 minus 3.6 divided by 3.4 minus 2.2. So the gradient is going to be 2. Now, if we compare the 2 equations with y is equals to mx plus c, if we compare these 2 equations, what is our gradient again? Log b is our gradient. Log a is our y-intercept. Fair enough. So we have, by the way, found out the gradient. So can we say log b is nothing but 2? Yes, we can. So the value of log b is 2, exactly 2. So now, can I find the value of constant b? Yes, I can. I can say b is nothing but 10 to the power of 2, which is again going to be 100. So I've already found out the value of b. So one of the constant I have found the value of. Great. Now, how do I find out the next constant, which is nothing but log a. I need to find the value of log a, or the constant a. Now, to do that, there are a bunch of informations that is available to me. I can use the coordinates directly to now find out log a. How do I do that? Let's take either of these coordinates. Let's take this one, right? I'm going to take the log y value as the x value as 2.2 and log y value as 3.6. And I'm going to plug it in into the main equation, the linearized equation. Let's try that, and it's going to be 3.6 is equals to log b. Did we find out? Yes, it is 2. Log b is nothing but 2. So let's plug that in, and x value, notice the x value is nothing but 2.2, right? 2.2 times 2.2, because log b times x, so log b value is 2 and x value is 2.2. Then add log a, which you're going to find out. So you're going to find out logarithm of a over here by making log a the subject. Now, if you make log a the subject, what is the value that you find? It's going to be 3.6. 3.6 minus 2 times 2.2. It's going to be minus 0.8. Is the value minus 0.8? Wait, minus 0.8. Now, 10 to the power of minus 0.8, 10 to the power of minus 0.8 is going to be 0.15 something. Now, is that the correct value? Yes, it is the correct value. A is going to be 10 to the power of minus 0.8. Hence, A is nothing but 0.158. Right? Fair enough. So, notice one thing. We have figured out both the values for the constant, and one is b is equals to 100, and the second one is a is equals to 0.15a. Notice 3SF, 3 significant figures, and the final answer is supposed to be 0.158 for the constant a. Fair enough. So those are the two answers, and that is part 1. Let's go for part 2. Now for part 2, they're saying find x when y is equals to 900. So they've given you the y value and they're asking you to find out the x value. Now there are two ways to do this. You can use the main equation without linearizing it, although you would have to eventually linearize it because you want to find out x. So ultimately you would have to, at the end of the day, use this formula. Because if you, let's say, if I give the example of using this directly, you know the a and b value by now. So they're giving you 900 is the y value, right? Y value is 900, right? Fair enough. So let's plug that in, and a is going to be what? It's such an odd number. 0.158 times what? 0.158 times b is 100. Yeah, 100 to the power of x. So how do you solve this now? You have to basically bring in logarithm and then again linearize the formula and then solve for x, make x the subject. Now for that, you already have an equation. You already have linearized the formula, this nonlinear formula. You have already linearized it. So why bother plugging it in into the main equation, whereas you can already plug the values into your main, your linearized formula that you have worked hard and found out. So log y, you don't know the log y value. Okay. So you know y is equals to 900, right? Can you find the value of log y? Very simple, bring log on either side. Log y, by the way, log base 10, right? Log base 10. So LG 900, what is the value of LG 900? If you want to keep it this way, you can keep it this way as well. But on a calculator, if you find the value of LG log of 900, it's going to be some odd value like this. Anyways, I'm going to keep it as log of 900, and let's see what happens. So I have LG 900 is equals to log of b, which is nothing but 2, times x plus log a, which is again what? Log a is minus 0.8. Minus 0.8. Fair enough. So let's make our x the subject. So log 900 plus 0.8 is equals to 2 times x. That divide both sides by 2 to make x the subject. And finally, if you put this entire expression into your calculator, you're going to get the most accurate value. So it's going to be log 900 plus 0.8 divided by 2 again. So our answer finally, x is equals to 1.877. So our final answer is going to be 1.88. Three significant figure, 1.88. So that is our x value to three significant figures, and that is going to be your question. Next question, let's go for this one, which is worked example 4 from your book. It says three of the vertices of a parallelogram ABCD. A is minus 10, 1, B is 6, minus 2, C is 14, 4. Find the midpoint of AC. Very simple. You know the formula for midpoints. What are the coordinates for A and C? A is nothing but minus 10, 1. C is 14 and 4. Let's find out the midpoint. Minus 10 plus 14 divided by 2. And again 1 plus 4 divided by 2. It is going to be your 2 divided by 2.5. Okay. So 2 and 2.5 is going to be your midpoint of AC. Now question B, find the coordinates of D. Now you know it's a parallelogram. So that is going to help you find out what the coordinate for D is going to be. So you have to, in these cases, draw a diagram to get a better idea of how to find out the value. There are a couple of ways to find this, I guess, but the formula for midpoint is probably going to help you the most. Okay. So let's first find out how the shape is going to look like, right? So it's going to be for A minus 10 and 1. Minus 10 somewhere over here, minus 10 and 1. This is A. And B is going to be 6 minus 2 somewhere over here, B. And C is going to be 14 far apart, okay? And it's going to be 4 somewhere over here, let's say. Now D. For D, it could be, let's say, over here. This could be a possible position for D, right? I'm going to mark it with red. So this could be a possible position of D. Or the other position that could be is this one. This could also be D. Now, could it also be any other place? So the point is, the point I'm trying to make is there are a bunch of position that D could have. But how do you know what the real position of D is going to be? The real position of D is basically that it's going to follow your alphabetic order or the order that they have already set for you. So they're saying the coordinates are going to be in the order of A, B, C, and next, obviously, D. So it's going to go either in this direction or in this direction, right? Now, for it to be clockwise like this, B should have been over here. B should have been over here, but B is not over there. So it's going to be anti-clockwise since A is over here, B is over here, C is over here. Consequently, D is supposed to be over here. Hence, if you look at their diagram, notice D is exactly over here, right? So you have to use your common sense a bit over here and notice that it is going to follow that alphabetic order or the order that they have set the question. For example, in this case, they've already mentioned it's going to go like A, B, C, D, like over here. Sorry, like over here. So you're going to follow the order that they have set, or usually at the alphabetic order. So you know D is supposed to be over here. So how do you find out this coordinate? You know the coordinates for A, you know the coordinates for B, you know the coordinates for C. How do you find out D? Very simple. Notice one thing. If I draw a couple of lines, you're going to be seeing something. So if I join D and B, and if I join, that's such a horrible line. I'll use another pen, wait. So if I join A and C, if I join D and B, right? Notice one thing. In case of several quadrilaterals, for example, rhombus, squares, then you have rectangles, then you have parallelograms. In these cases, what you're going to notice, not all quadrilaterals, but such symmetrical ones, for example, your rectangles, squares, rhombus, parallelograms. In these cases, what you're going to see is if you join the opposite corners or the opposite vertices together, you're going to notice they're going to meet at a point that is the midpoint. That is the midpoint for either pair of vertices. What do we mean by that? So for A and C, notice this point of intersection is the midpoint of AC. Is what? The midpoint of AC. Now for D and V, this point of intersection is again the midpoint of D and B. This is going to give you a good pointer to how to find out the point or coordinates for D, because you know one piece of information, that the midpoint midpoint of AC is also the midpoint of DB. If I write that down, MP of AC is exactly equal to the MP or midpoint of DB. So can I find out the midpoint and then try and figure out the coordinate of D? Because I'll know two things. I'll know the coordinate of midpoint. I'll also know the coordinate of B. These two pieces of information I'll know, which will help me find out the coordinate of D. How will it do so? Let's find out. Let's see how to do it. So if we go by their example, what example? Notice I will first have to find out the midpoint of AC, which again is the midpoint of DB. So to find out the midpoint of AC, we have already done it in part A. So they've already made it easier for us. So the midpoint we know to be is 2 and 2.5. This again is the midpoint of DB. So if we had to, notice, if we had to find out the midpoint of DB, how would we do it? We would say that let's consider the coordinates of D as X and Y, by the way. This is going to make it a bit simpler. So you know the coordinate of D as X and Y, you know the midpoint, you know the coordinates of B. Normally, how would you find out the midpoint of DB? It would be X plus the point for B, which is what? 6, right? X plus 6 divided by 2. This is supposed to be the midpoint X coordinate for the intersection point. And the mid Y coordinate is going to be Y plus, what is B coordinate? Minus 2. Minus 2. Divide by what? 2. Now, do you already know the midpoints? Yes, you do. So I can make this simpler and say my answer is going to be X plus 6 divided by 2 is supposed to be 2, because you already know the midpoint. You already know the midpoint. So X plus 6 divided by 2 is supposed to give you 2. Similarly, your Y, was it minus 2? Yes. Y minus 2 divided by 2 is supposed to be 2.5, because you already know the midpoint, 2.5. Now, can you make X and Y the subject, which is again the coordinate of D? You can make X and Y the subject over here and say it's going to be, for X, it's going to be, I suppose, minus 2. And for Y, it's supposed to be, I guess, 5 plus 2, 7. So it's going to be, the D coordinate is going to be minus 2 and 7, right? Yep. So they've done the exact same thing. They've used the formula for midpoint to find out the coordinate for D. And this is going to be the simplest way for you to find out the unknown coordinate in any parallelogram, right? This is also applicable for several other cases as mentioned, for example, square, rectangle, rhombus, and in case of such, symmetric quadrilaterals. Fair enough. Now, I mentioned there are a couple of ways to find answers. The other way, notice, could be finding the gradient. I mean, forming line equations. That is what I mean. So you would have to find the gradient of dB, which you couldn't. You would have to find the coordinate of AD, because D you wouldn't know. So find the gradient of AB. Find the gradient of BC. Why, you ask? So if you know the M, notice M of AB and M of BC. Granted, you have found these two values. The next thing you do is form an equation for this line. Now, isn't this line, the shaded line, exactly parallel to your AB? Yes, it is. It is parallel to your AB, right? So the gradient for AB also applies to the gradient for this shaded line, right? Great. So you're going to use this coordinate, right? You're going to use that coordinate, this C coordinate, and the gradient of AB to form a straight line equation. And that I'm pretty sure you know already how to do. You're basically going to write it as y minus y1 is equals to m times x minus x1. X1 and y1, you're going to take the values, the coordinates of C and the gradient you already found out from A. The same thing you're going to do for this line. Where do you find the gradient of BC? So you find the gradient of BC and you take the coordinates of A and form an equation for this shaded line. For what? This shaded line. So now you have two line equations. You have what? Two line equations. After you find the two line equations, you're going to solve simultaneously and say y is supposed to be equal to y because both of these lines, both of these lines or line equations are supposed to meet, intersect at a point. Which point? Point D. It is supposed to meet and intersect at coordinate D. And by solving y is equals to y, in that case, again, you will find the coordinate of D. So that is another lengthy way to find out the answer, which again, I would never advise a student to do in this case because you want to save your time. So that is not something you do. But if you never, I mean, if the thought of finding the midpoint doesn't come to your head, you'll definitely have to go for solving the line equations. Otherwise, is there any other way? Not that I remember right now, but those are the two methods I have in my mind. Anyways, so next question. This is interesting. So the first part, the coordinates of triangle PQR are P minus 3 minus 2, Q 5 10, and R 11 minus 2. So they're giving you the three coordinates of the triangle. Find the equation of perpendicular bisector of PQ and QR. I've drawn the coordinates. This is Q, P, and R. Fair enough. Always drawing the diagram is the best thing to do. It's going to make your life easier while solving these questions. So find perpendicular bisector of PQ. You already know what the perpendicular bisector is. The line that is going to be perpendicular to PQ and also going to run through the midpoint of PQ. Those two things. So they're asking you to find the perpendicular bisector. First thing you do, find the midpoint. How do you find the midpoint? Take the two coordinates of P and Q, find the midpoint. So it's going to be minus 3 plus 5 divided by 2, and again minus 2 plus 10 divided by 2. Fair enough. Do that and you're going to find the midpoint. You found the midpoint? Great. Next thing, you're going to find the gradient. What is the gradient of PQ? Find it out. Rise divided by run. And your gradient turns out to be 3 by 2. Fair enough. So you now know the midpoint, you now know the gradient of PQ. Now, what do you know about the gradient of the perpendicular bisector or the line that is normal to your gradient? It is supposed to have a gradient that is negative and reciprocal. So it's going to be minus 2 by 3. Minus what? 2 by 3. Negative reciprocal. Very simple. Now that you have done that, what are you going to do? You're going to form the equation. What is it going to be? Y minus y1 gradient times x minus x1. This point is the midpoint that you found out. Y coordinate of the midpoint. And this again is the midpoint, the x coordinate of the midpoint. Great. So next thing, by the way, the gradient over here. And now you make y the subject and you form the equation. Either way, whichever you keep, it's supposed to be all right. In this case, you have fractions. If you don't want to keep fractions, you can write it this way. No problem. Next one, 2, same type of question. Find the midpoint, find the gradient. The negative reciprocal is going to be the gradient of your perpendicular bisector. Form the equation. Either keep it as it is, as a fraction, or write it as 2y is equals to x. No problem. This is the easy part. The hard part is find the coordinates of the point which is equidistant from P, Q, and R. First, take your time and understand this question. What is it even asking you to do? Take your time, pause the video, understand part B. Now, to explain it, they're asking you to find such a coordinate on the plane of these points. Such a coordinate, let's say over here, 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 or here. You have to find it out. What is the coordinate from which the points P, Q, and R is supposed to be equidistant? What does that mean? Equidistant means same distance from that coordinate. Hence, let's say this is the point. From this point, your P, R, and Q is supposed to be equidistant, meaning it should have the same distance. But notice one thing. You can see that from this point till R, the distance is much larger compared to distance from P and Q. So this is definitely not a point from which all points of the triangle is going to be equidistant. So how do we even find the equidistant point? That is the question. Now, I have plotted the points on Desmos, P, Q, and R, P, Q, and R. So notice one thing. The point that is equidistant is somewhere inside the triangle over here. Is what? Somewhere inside the triangle. Because wherever you draw the point outside the triangle, it is never going to be equidistant. Notice the distance of this point till P, till Q, and R. It varies so much, right? Similarly, of this point till Q, till R, till P. This is shorter, longer, again, somewhere in between. So, by the way, you can't also randomly find the coordinate. You have to use math over here. And the trick or the knowledge that you need to have to solve this question, I don't think this would come in your paper, but because you need a bit of information before even trying this question. And that bit of information is whenever, notice carefully and listen carefully, whenever you draw perpendicular bisectors from all three sides of the triangle, the point at which the bisector intersects is supposed to be the point from which all the vertices are equidistant. I repeat, whenever you draw perpendicular bisectors from all three sides of the triangle, the point at which the bisectors intersect is supposed to be the point from which all the vertices or corners are going to be equidistant. I hope you've written it somewhere or pasted it in your head, because if such a question comes in your paper, it's going to be quite difficult to remember this. But you can also do a bit of trial and error and find out, because notice one thing, the few bits of information you're learning in this syllabus is related to gradient, perpendicular bisectors, and logarithms, linearizing, all that. So out of nowhere, they're not going to throw a question without you having the necessary bits of information or formulas. So over here, you already know to an extent that you have to work with the idea of perpendicular bisectors, right? So with that, you can make a smart guess that you have to find the perpendicular bisectors of the sides, and in return, you would also find out that the point at which they would intersect might be the point from which all the corners are equidistant, right? Fair enough, but I mean, I don't expect you to guess it spot on. But you can also take another example over here if you're not convinced with the idea that I've just shared. So if you let's say this scalene piece of triangle, which is This is, by the way, again scaling as well. This is not equilateral triangle. I thought initially this is supposed to be an equilateral triangle, but this is not. This is scaling as well. But if you take for example this one, the equidistant point lies outside the triangle over here. So it's an interesting example. So notice this is the perpendicular bisector for if I find ABC. So for AB, this is the perpendicular bisector, right? And again for CA, this is the perpendicular bisector. And again from AC, this little line is the perpendicular bisector, right? So when you see the intersecting point, this intersecting point, now from that white intersecting point, draw a bunch of lines. This one. What am I doing? Okay. And this one and this one. If you do not believe me, take a scale and measure the distance from this white point or the equidistant point coordinate till the vertices of the triangle, that is A, B, and C, and you will see the distance is exactly the same. So that white point is nothing but the equidistant point from which all the sides, sorry, all the corners are going to have the same distance, right? So that is the trick over here, right? That is the only bit of trick over here. You have to find all the perpendicular bisectors of all the sides and then equate all of those together. And only then are you going to find the coordinate. Anyways, you already know two of the lines, right? So they've made it easier for you. You know one of the coordinate, sorry, one of the equation of the perpendicular bisector, that is of what? This is of QR. So this is of QR and PQ. This is of PQ. So two lines are enough to find the intersecting point, right? So these 2 points, again, you're going to use y is equals to y, solve simultaneously, and you're going to find the coordinates, that is x is equals to 4 and y is equals to 2. So the doing part, the calculation part is very simple. The fact that you have to figure this out is the hard part, right? That is the challenge part of this question. So anyways, you're going to solve simultaneously and find the point of intersection, which is going to be equidistant from all the vertices. Fair enough. Now, this point is not exactly added in your book, but I feel like I should add this because this can be a bit important in some cases. So this is basically saying that whenever you have, let's say, a straight line, and the question is telling you that it is divided into a ratio, and they've given you two endpoints. Let's say A and C. They've given you the coordinates of the endpoints of the line, right? And they're asking you to find the point that respects the ratio of, let's say, 2:3, an example, right? So AB is such a part of the line where the distance is 2/5 of the entire line. Again, BC is such a part of the line that is 3/5 of the entire line. Why 3/5 and 2/5? Because the line is divided into a ratio of 2:3. So 2 parts with AB and 3 parts with BC. So how many total parts? 2 plus 3, basic maths, 5. So the total number of parts are 5, where 2 of those are with AB and 3 of those are with BC. Very simple. But the point is, how do you find out this point B, which respects this ratio? How do you find the B? Now, for this, you can use a very simple equation, and I'm going to tell you that exact equation for the coordinates. These two equations are in the same one, just for different coordinates. So the equation says, if you want to find this point in between, or let's say you know A and B, but you want to find out C, even that you can do. You have to keep the point C as, let's say, x and y, and you have to find for x and y. Anyways, point is, any point that is not given, you can find out using this formula. And the formula says x1 times n plus x2 times m. Now, what is n and m? The ratio. I'm just writing it as m and m. You can write a, b, whatever. I'm just expressing the formula as m and n. No problem if you have any other constant or any other alphabet. But you're writing this as x1. So the endpoint, the x coordinate of the endpoint times n, which is this part is n, this part is n, and this part is m. Now, when we are going to be working with the values, in this case, close to 3, I'm going to directly write 2 and 3. But in this case, I'm expressing the formula. So I'm using m and n. Anyways, endpoint times this ratio. And again, this endpoint x2 times this ratio. Okay. So you're going to multiply one of the endpoint with the opposite ratio, which is m, and another endpoint with the opposite ratio. Great. You're going to add both the products. Add both the products. And you're going to divide by what? The total number of parts, which is 2 plus 3, 5. So m plus n. Okay. Fair enough. So you're dividing by 5 in this case, or the sum of the ratios. Now the next one, for y, the same thing. The endpoints are going to be now your y coordinates, not your x coordinate. It's going to be your y coordinates. Very simple. So you're going to take this endpoint, multiply with this ratio, which is m, and you're going to take this endpoint, multiply with this part of the ratio, which is m. So y times n, y1 times n, and y2 times m, right? And then divide by the sum of the ratio, which is 5 in our case. So that is how you find out the coordinates of b. So the first one you found out the x coordinate. Second one you found out the y coordinate. What do you do for x coordinate? One calculation. For y coordinate, another calculation. Very simple. Great. So I'm going to work with the example that we have, 2:3. So for x again, the x coordinate of b, I'm going to say, for the x coordinate, I'm going to say 2 times 3, because this ratio is 3. So 2 times 3, 2 times 3 plus 12 times 2, 12 times 2. Divide by what? 2 plus 3, 5. Now when you find the answer, it's going to be 6. Next one, again for y, same thing. It's going to be 3 times 3. So 300, wait, what? Okay, sorry, I did it over here. 3 times 3, and again, y coordinate 3 times 2. 3 times 2. Right? So the order doesn't matter. Since you're adding it up, the order doesn't matter. So 3 times 3 times 3 times 2 divided by 5, the sum of the ratio. And the final answer that you get is 3. Now this is one way to do it. This is what? One way to do it, which is directly using a formula, a shortcut. Now there is also another way to do it, which is a bit of a lengthy method. Granted, you don't know this formula because it's not written in your book. There's also another way to attempt this question. That is by using the idea or notion of distance. Because they've given you the ratio, you can now take the benefit of the distance formula, which you've learnt about in this video only. Right? How do you do that? I'll show you. I mean, my suggestion is using this formula directly, which is going to save you a lot of time. But if you don't remember it, you can use the alternative method, which is probably the one the paper wants to see you use in some cases. So this one basically is you have to first find out the entire distance. You have to find out what? The entire distance. That is of AC. Of what? AC. Now, can you find the entire distance of AC? Yes, you can. You know the points of A, you know the points of C, you know the distance formula. So find out the distance AC. AC modulus means distance AC. So 12 minus 2, x1 minus x2 whole square, and then y1 minus y2 whole square. Great. So the distance turns out to be 10 units. What? 10 units. Now, what you're going to do is you're going to find the distance AB. How do you do that? Do you know the coordinate for B? No, you don't. You don't know the coordinate of B, but you know one important thing, that is the ratio. That is what? Ratio. What do you know about the ratio? AB is supposed to be, remember I mentioned in the beginning, it's supposed to be 2/5 of AC. 2/5 of what? AC. Because the ratio is 2:3. So 2 parts of the entire line is going to be AB, right? 2/5 of AC is going to be AB. So in case of distance as well, the 2/5 of the distance AC is going to be AB. I'm going to use that idea and say 2/5 of AC is going to be 4, right? Fair enough. Now, how does that help me? It is going to help me form one equation. What is the equation? I'm going to form an equation with the help of distance formula. Now, you don't know the coordinate of B, but you know the distance of AB. So I can form an equation using X and Y. How do I do that? Notice, I don't know the point X, I don't know the point B. I don't know the X coordinate of B, but I know the X coordinate of A. What is the X coordinate of A? 2 and 3, in 2, and Y coordinate is 3. So 2 and 3, 2 and 3. So x minus 2 whole square plus y minus 3 whole square. And root over that value is supposed to be 4. Why? Because I'm finding the distance and I already know the distance to be 4. Now square both sides and it's going to be 16 is equals to this expression. That is under the root. Now you have removed the root by squaring both sides. What do you have at the end of the day? You have an equation with two variables x and y. Now, is this enough for you to find xy, which is the coordinates of B? Xy, by the way, is the coordinate of B. Remember? So I want to find the coordinate of B. That is the main objective. Forming this equation doesn't help if I can't find the coordinates xy. Right? So how do I find xy over here? I formed an equation, but how do I find xy? Remember one thing. Remember this. Whenever you have a set number of variables in an equation, you also need the same number of equations to find the value of those variables or either of the variables. What do I mean by that? In this case, in this equation, how many variables do you have? X and y, which is two variables. So how many equations do you need? Two, right? How many equations do you need? Two. So this one equation is not going to help you find the coordinate of B. Let's say in a hypothetical situation, you have three variables in an equation. How do you find those three variables? You have to form three different equations. In this case, I formed an equation with the help of distance. Can I form another equation with the help of any other metric? I can. I also know the formula for gradient. Does this line have a gradient? Obviously it does. It's supposed to have a gradient. So can I use that to find another equation with respect to gradient? I can. Notice one thing. This is a straight line. The points A, B, and C are collinear. Are what? Collinear on the same line. And remember, in this video, towards the beginning, I mentioned something. That the gradient M of AB is supposed to be the same, exactly the same compared to M of AC. This is very important again, right? So the gradient of AB, a small segment of the line, is supposed to have the same gradient compared to the entire bit of line, right? So the gradient doesn't change. You know the the coordinates of AC. Do you know the coordinates of AC? You do. So using that only, you can find the gradient that is of AB as well, because the gradients don't change on the same line. Because common sense, if you have the same line, the gradients at any point is going to be the exact same. That is in case of a straight line. and this is a straight line. It's a collinear set of points. Hence, finding the gradient of AC will help us. So let's find the gradient of AC. What is the gradient of AC going to be? The gradient of AC is going to be, again, rise divided by run, 3 minus 3 divided by 12 minus 2. If you take the coordinates, and the answer is 0 because it's a horizontal line parallel to the x-axis. If you had any other gradient, no problem, that would help us as well. So you found out the gradient of AC. Is this the same gradient of AB? Yes, it is. Can I use that idea now? Yes, you can. So if this is the gradient of AC, I can form an equation of what? Notice. The gradient of AB is supposed to be what? Y minus 3 divided by x minus 2, right? And this is supposed to equal to 0 because the gradient is 0, right? Let's use this idea. So my gradient of AB is supposed to be y minus 3 divided by x minus 2. Agreed? Fair enough. So let's make y the subject over here. Just like any line equation. It's going to be, and finally what you get is this, a straight line. So now by making y the subject, I find another equation, that is of y. Now in any other case, when the gradient is, let's say, any other value but 0, you would have, let's say, 2x plus 3, any such value over here, any such expression over here. But in this case, in our case, it's a straight line. I mean, it's a horizontal line, which is why you get an expression without x. But anyways, this is going to help us as well. In all of the cases, you can apply the same formula and you will get the right answer. So this is our second equation. And now, what did I tell before starting the calculation? I said, wherever you have two variables, you need two equations to find the variables. Now, do you have the second equation? Yes, you do. Is it going to be enough to find your answer? Yes, it's going to be enough to find your answer, which is the coordinate of B. Which is what? The coordinate of B. So, what am I going to do? I'm going to solve simultaneously. I'm going to substitute over here. I'm going to substitute this expression into our main equation, which was of the distance. Notice, I had a distance equation. And I realized I have two variables, which is not going to be enough. So I added another parameter, which is of the gradient. I formed another equation. With the help of the gradient. So whenever you're in a situation similar to this, where you have one equation only to find the answer, you have to understand that I need another equation by using anything. In this case, I have gradient. In this case, I have what? Gradient. So I'm using that to form another equation, which is going to help me find coordinates of B, right? Kind of. So this is the second line, the second equation, and I'm going to put this in the first equation. So if I plug this in, y minus 3, I guess. So I plugged it in over here. And now you can open the brackets and you are going to find a quadratic equation. If you simplify everything, it's a quadratic equation. And now if you factorize it, you're going to have two values, one of which is going to be clearly wrong. One is this, the other is this. Now x can't be negative. Why? Because a is positive, c is also positive, right? So the coordinate in between is not going to be negative. So that tells you that x is not going to be minus 2. So this is not applicable. And your final answer is 6. Does this match with our initial method? Is x 6? Yes, it is. It is 6. Right? And the y coordinate, again, remember we carried out the gradient process. That in return helped us find out the y coordinate of D. Because you are finding out, notice, you are finding out the gradient of AB. So you took the points of B, which is y and x, and you are forming an equation with it. And in return, what you found out was the y coordinate of B, which is 3, right? So that is how you can solve this same question using the distance method, right? So there is almost always an alternative method. If you don't remember the shortcut or the formula, you can form different equations using the information that you have to get to your answer, which is finding the coordinates of B in this case, right? I hope I could simplify everything. And if you don't understand this, try it out yourself. Take another example and use the distance formula and the gradient formula to find your coordinate in between, right? Great. Again, next question. The coordinates of three of the vertices of a parallelogram ABCD. A is -4, 3, B is 5, -5, C is 15, -1. First question, find the coordinates of the points of intersection of diagonals. So, find the coordinates of intersection. Okay, look, whenever you have a parallelogram, I've already mentioned with the last to last question, I guess, the point of intersection is going to be midpoint of both the opposite vertices. So whatever the midpoint of A and C is also the midpoint of D and B. So you can find the intersecting point by using any pair of opposite coordinate, and finding the midpoint of that. So find the midpoint of the given two coordinates, which is A and C. Find the midpoint of it. It's going to be -4 plus 15 divided by 2 and 3 minus 1 divided by 2. You get the midpoint, which is again, that midpoint is going to be the point of intersection. Fair enough. So it's going to be 5.5 and 1. That is your answer for A. Find the coordinates of point D. How do you do it? Very simple. We just discussed this in the last question. You're going to find, you're going to use the midpoint formula. So the midpoint of AC is also going to be the midpoint of DB. So use that idea and say, I know the midpoint of DB, but I need to find the coordinate of D. So the midpoint, the X midpoint is going to be 5.5 as over here. And the coordinate of D is going to be X, and the X coordinate of B is going to be 5 divided by 2 is supposed to give me 5.5. Do the same with the Y coordinate, and you're going to get the coordinates for D. Right? Fair enough. So you get the coordinates of D, and A and B is simple. What I really wanted to do was find the area. So they're asking you to find the area of the parallelogram ABCD. Okay. So in this case, let's again find the area. So we're going to use the same formula we discussed towards the beginning of this video. Line up all the coordinates A, B, C, D, and again A, right? -4, 3. Fair enough. And it's -5, 5, -5. Okay. So these are the coordinates. And what are you going to do right now? You're going to do multiply and add. So it's going to be -4 times -5, 5 minus 5 times -1, 15 times 7, and 6 times 3, right? Great. Now you're going to subtract these products. 5 times 3, 15 times -5, 6 times -1, and -4 times 7. Okay. So you find the sum of all this, in the bracket, and finally you're going to find the difference of both the sum, right? Find this sum, and then find the difference. Whatever the answer is, you're going to take half of that value as your area. As your what? Area. Okay. This is called the shoelace method. What? The shoelace method. And this is going to help you find any sort of area of any rectilinear figure. That is, let's say this is one of the figure. Can you find the area of this? You can, using the vertices. If you have all the vertices, you can find the area of the sheet. Next question. What is this? So this is again relevant to your use of logarithms. You have to, I guess, linearize or what? They've given you the points. Let's read the question quick. So variables x and y are related so that ln y is plotted on a vertical axis and ln x is plotted on a horizontal axis. A straight line passing through the points 1 to 4, 1 is obtained. Express ln y in terms of x. Okay. So ln y on the vertical axis, ln x on the horizontal axis. Great. And they've given you 2 points. 1, 2, which is 1 and 2 over here, and 4 and 11. 4 and 11 somewhere over here. Fair enough. So you know the 2 points. What are they asking you to find? Find an expression in terms of x for ln y. Now, if it's a straight line, it's going to follow this mx plus c. But they want it in terms of what? Ln y is equals to m ln x plus c. Okay, fair enough. Why in terms of ln x? Because they have already given you this bit of information that ln x is on the x-axis. Hence, the coordinates, the x coordinates are the ln x values, right? The x coordinates are what? Ln x values. So your straight line equation is going to be ln y is equals to m times ln x plus c, right? So in this case, you might get confused because they've written in terms of x. If they wrote in terms of ln x, it would have been easier for you to understand, but it's all right. They've already told you that ln x is plotted on the x-axis. So you have to understand from that that your main equation is going to be in terms of ln x, right? Fair enough. So knowing that, I'm going to find what? Two constants. The gradient and the y-intercept. How do you find that? Simple. Use the data given and you're going to see 11 minus 2 rise over run 4 minus 1, and this is going to be your gradient. So you already know m. Okay, so after you find a gradient, you're going to find the y-intercept or c over here. How do you find that out? You already have the points given, the coordinates, I mean. So use any other coordinate, doesn't matter. I'm going to take 1 and 2. So ln y minus 2 is equals to the gradient times ln x minus the x coordinate, which is 1. Right. So simplify everything and you will have an equation in terms of ln y and ln x. That is going to be ln y is equals to 3 ln x minus 1. Very simple. Next question. Express y in terms of x. Now what do you do? They're asking you find or express y in terms of x. Fair enough. So the only way to deal with this is you have to non-linearize the formula. How do you do that? I'm going to show you. So the main equation is ln y is 3 ln x. I've written directly over here, but I'm going to explain. Wait. So this is your equation from part A, right? So they're asking you express the entire expression in terms of y. I want the expression in terms of y and x. How do you do it? You have to non-linearize it, meaning you have to remove the logarithms. You have to remove the ln function from the equation. So can you do that? Yes. How do you make y the subject over here? You have to say y is equals to e to the power 3 ln x minus 1. Can you see this? Yes, you can. I'm going to break this equation into ln x cube times e to the power minus 1. Okay, fair enough. Now notice one thing. By the way, what did I do over here with the e stuff? Whenever you have, let's say, e square, let's say, can I write it as, isn't this the same as e times e? It is the same, right? Because when you have two e's multiplied, the powers add up. So 1 plus 1. If I have, let's say, e to the power of 3, can I say it is e to the power 2 times e to the power 1? I can say it because the powers add up to 3. Add up to what? 3. So that is the exact same thing I've done. Notice, if this is the entire power, I'm breaking it down. I'm doing what? Breaking it down. So I've written it as 1 is going to be e to the power of ln x cube. So I've put the 3 as power of x, because whenever you have, let's say, ln x to the power 3, you can bring it in front of the logarithm. Similarly, if you have in front, you can bring it as the power of the term inside, right? So you can do that as well. So no problem over there. But the one I want to share is breaking the terms apart. So if you have anything, let's say e to the power of n plus 1, can you break this and say e to the power n plus, sorry, times e to the power 1? You can. Because if you simplify this as well, it's going to be e to the power n plus 1. No problem. So if you have e to the power n minus 1, can you say e to the power n times e to the power minus 1? Yes, because ultimately this is also e to the power n minus 1. So all of that is all right. Okay. So I hope you're not confused about this step. So I'm going to continue solving this. Now, notice one thing. E to the power of ln x cube, this part. This e and ln is going to be cancelled off. Now, some of you might be confused about why this happens. I'm going to explain in short why this happens. Let's forget inside is x cube. Let's say it's a simple term 2. Simple term 2. What happens in case of ln 2? Ln 2 is telling you, okay, ln 3. So what is ln 3 telling you? Ln 3 is telling you what power of e do I need to have the same term as 3 or the same value as 3. What should my power of e be? What should the power of e be to get the exact value as 3? So let's say you have, ln 3. The power of 3 that you need is, power of e that you need is 1.0986. E to the power 1.0986 should give you the same value as 3. Notice, ln 3 is going to be what? 1.0986. Agreed? Great. If you find it in your calculator, the value that you get is 1.0986. So if you have e to the power of 1.0986, what is the value you're going to get? You're going to get the same value again. That is 3. You can try it for yourself. You can try it for yourself and see that ultimately the e and ln cancels off. Because with the ln function, you're telling the question, or you're telling me that you need a certain power of e to get or give the same value as 3. And that value turns out to be what? That value turns out to be 1.0986. And that same value, you're again putting it as the power of e. So ultimately, you're going to get the same term, 3, over here. You're going to get what? The same term back. So the e function and ln function cancels each other off, right? So again, I've explained this over here with ln 3 as an example as well. So you can check this out. If you don't understand my verbal explanation for some reason, you can read it and understand. Point is, the e and ln cancels each other off, right? So ultimately over here, what will you be left with? You're going to be left with x to the power of 3, because that's the term inside, right? So you're going to be left with x to the power of 3 because e and ln cancels each other off. X to the power of 3 times e to the power of minus 1. Ultimately, your equation is going to be x to the power of 3 divided by e. This is ultimately your answer. Is that it? Yes. So you have non-linearized your equation. How do you do it? You remove the ln functions. How do you do it? You're going to put the e as the base of the entire left hand side. You're going to do what? You're going to put e as the base of the entire right hand side expression. What is the right hand side expression over here? 3 ln x minus 1. And in case of removing the logarithm, you have to put the base on the right hand side, and you have to put the entire term or expression on the right hand side as the power of that base. So if you're removing the ln over here, you have to bring the base to the right hand side, which is e in this case, since it's a ln function. And the entire right hand side expression is going to become the power of that base. It's going to become what? The power of that base. Okay. So that is how you remove the logarithm sign, and that is how you're going to find ultimately the non-linearized expression, that is in terms of y. Fair enough. So that is how you're going to solve this. And last question, I guess. Last question, they have given you a set of data, x and y. The table shows experimental values of variable x and y. The variables are known to be related by the equation y is equals to a divided by x plus b, where a and b are constants. Draw the graph of y against xy. So they're asking you to draw a graph of y in terms of xy. So you basically have to plot the points. That's a very lengthy thing to do. Anyways, you have to plot the points. So you have to find xy as well. If they're telling you y against xy, y is going to be on the um, y axis. So y on the y axis and xy is going to be on the x axis. Fair enough. Now find the value xy. How do you find the xy value? The product of x and y. Very simple. 0.2 minus, zero point 0.2 times 36. The value 0.4 times 12, 0.5 times 9, 0.7 times 6, zero point 0.9 times 4.5. Simple. Now plot all these values and you're going to get this line, right? I've used Desmos to find the line because I can't sit down and plot the values. Anyways, so that is how you find the line. You have to plot it. And part B is asking you, use your graph to estimate the value of A and the value of B. So you have to, again, you have to linearize this formula. Okay. So over here, whenever they ask you to find the constants, basically you have to linearize the formula in terms of a straight line equation. And in this case, you know it's a straight line. So again, you have to linearize the expression. This is what? Non-linear, right? This is what? Non-linear. So you have to linearize this expression. Okay. So to do that, you're going to say um yx. Over here, by the way, you don't need to bring in logarithms because as you can see, if you multiply y to the over x plus b to the other side, you're going to get the expression in terms of y and xy. So they're not asking you to find the gradient of um a graph that is y against x. Rather, they're asking you to find the gradient of the line that is y against xy. If they would ask you to find the gradient of y against xy, y against x, not y. In that case, it would be a curve, right? Because it is 1 by x over here. So it's going to be a curve in that case. So it's going to have varying gradients. It's not going to have one gradient. So they're not going to ask you that. They're going to ask you the gradient of y against what? Xy. So in that case, you don't have to bring a logarithm or anything as such as that over here. Because if you multiply x plus b to the other side, you're going to get the same thing. And automatically it's going to be linearized because you're finding the gradient of y against xy, right? So to show what I just explained, if you multiply x plus b to the other side, it's going to be yx plus yb. Now if you take the x and y intercept to the other side, that is yx and a to the right hand side, you are left with y. So now to make y the sole subject, you're going to take b and divide on the right hand side. So ultimately it's going to be y is equals to minus 1 by b yx plus a by b. Now notice one thing. What are the similarities with y is equals to mx plus c? What is the c over here? A by d. What is the m over here? Minus 1 by d. So notice your x coordinates are actually yx, right? Your yx are the x coordinates. So that is why over here you don't need to bring in any sort of logarithm. This is good enough. Anyways, you're going to now do what? To find out your gradient, you're going to simply use the data that is already given to you, uh, that is of the graph, and that is going to be enough to find your constant b. They ask you to find the constant, no? Yeah. So find the gradient of the line by using the coordinates given. So any two coordinate you take, doesn't matter. So I'm going to take these pairs of value, find the gradient. The gradient turns out to be 10. Okay. So now you know the gradient. You can use that to find the b value, because you know minus 1 by b is the gradient. So b is going to be ultimately minus 0.1. If you know the gradient, that is 10, you can take any of the value. Let's say, which one did I take? 4.5 and 9. Which one is that? This one. So let's say you take this coordinate and you know the gradient, you can form an equation using y minus y1 is equals to m times x minus x1. You're going to form an equation using that. Now, when you simplify everything, you're going to get this straight line equation, which is y is equals to 10x minus 36. Now, you already know the gradient, which is 10. The point of doing this was to find the y-intercept, which is minus 36. So you're going to equate minus 36 is equals to a by b, and hence, since you know the value of b, which is minus 0.1, plug that in over here to get the value of a. So the value of a turns out to be 3.6, right? Okay, so there is part C as well. Oh, to repeat what I did over here in B, very simple. I compared with y is equals to mx plus c, and I found out the constant b by equating the gradient to minus 1 by b. That was the first part. Second part was I took any of the point, right? You can take any of the points on the line, that is 7.236 or 4.812, doesn't matter. Take any of the coordinate and use the x and y value and the gradient that you just found out, to form an equation, a straight line equation, which is to find the y-intercept. So by finding the straight line equation, you just found out the y-intercept, which is again what? A by b, which is going to be exactly equal to a by b, because in your linearized equation, notice a by b is the y-intercept. So you're going to equate the y-intercept with a by b to find out constant a, and constant b you already found out. So that is it. Very simple. And for C, they're asking you, without drawing a second graph, estimate the gradient and intercept on the vertical. Oh, wait, there's an extra part. Sorry. An alternate method for obtaining a straight line graph for the equation y is equals to a by x plus b is to plot x on the vertical axis and 1 by y on the horizontal axis. So it's going to be x against 1 by y. Fair enough. Without drawing a second graph, estimate the gradient and intercept on the vertical axis of this graph. Okay. So they're asking you to find out the gradient and intercept on the vertical axis of this graph. So what they're asking you is x against 1 by y. What is going to be the gradient and what is going to be the intercept? Very simply, what did they ask not to do? Without drawing a second graph. Okay, you don't need to draw anyways. So what you would do is basically find a pair of value. You have to find what? A pair of value. How? You already know the x coordinates 0.2 and 0.4, which is given to you. Let's say I take these two values. You can take any two, doesn't matter. You can take any two, doesn't matter. I'm going to take 0.2 and 0.4, right? So 0.2 and 0.4. And again, the 1 by y value is going to be reciprocal value of the y values. So it's going to be 1 by 36 and 1 by 12. 1 by 36 and 1 by 12. So now you know two different coordinates. So this is going to be basically like this: x on the y-axis and 1 by y on the x-axis. So let's say 0.2 and 1 by 36, this one, and 0.2 and 0.4 and 1 by 12. So this one. So let's say this is your zero point 0.2 and 0.1. So I found out two sets of coordinates. How does that help me? It's going to help me find out the gradient, and it's going to ultimately help me form an equation to find the y-intercept. So you're going to do the same thing. The only different part over here is I have found out two different sets of coordinate. I had to calculate the coordinates because 1 by y is not given to you. So what did you do? You found out 1 by y. Okay. So you took any two values and you found out 1 by y. Great. So to find the gradient of this line, which is x against 1 by y, don't get confused by, x on the y-axis and 1 by y on the x-axis. Don't get confused by that. The way it is, you're going to find the gradient. What is the rise over here? The change in x value. And what is the run over here? Change in 1 by y value. So you're going to take 0.4 minus 0.2, 0.4 minus 0.2 divided by 1 by 12 minus 1 by 36. Right? Great. And the gradient is going to be 3.6. So you know the gradient. Great. Now can you formulate an equation? Yes, you can. So x minus, take any of the coordinate. I'm going to take this one. And it's going to be x minus 0.2 is equals to gradient times 1 by y minus 1 by 36. 1 by 36. Okay. So now simplify all this and you're going to get x in terms of 1 by y, which is ultimately what they wanted, which is x on the vertical axis and 1 by y on the horizontal axis. So our straight line equation respects that statement. So ultimately, did you get the y-intercept? Yes, you did, which is 0.1. So y-intercept is going to be x is equals to 0.1 and your gradient is going to be 3.6. So without drawing a diagram or graph or plotting a graph, we have found out by converting the coordinates. By converting the coordinates, any two set of coordinates I have taken and converted the coordinates to respect the statement they have given us. That is, we need this straight line to be in terms of x and 1 by y. So I converted the y values into the reciprocal value and I found the gradient of x and 1 by y. So ultimately, by finding the gradient and taking any of the point, I found an equation. From that equation, I ultimately got the y-intercept. In this case, that is going to be the x value. The what value? X value. Why? Because the x value in this graph is on the y-axis. So don't get confused by y-axis and x-axis and all that. Whatever variable they're putting on the y-axis, you have to consider that as the rise, and whatever variable they're putting on the x-axis is going to be your run. Fair enough. So that is pretty much it. I have done a lot of questions in this video because it's a simple topic, straight line graphs. Like someone else would probably just show you the three formulas and that's it. But this is sort of the basis of everything. This is going to be the basic and the fundamental for you to be able to solve a lot of questions. A lot of questions are going to take these fundamentals, twist the idea, and give you a lot of different questions. So you need to practice a lot of sums, and I've sort of given you all different sorts of questions that the paper can give you to practice and show you that even if you have something out of ordinary or you have not practiced it, you can always find an alternate method to find the answer to that question. So don't get scared and don't get worried. I'm going to come up with different videos and I'm going to solve a bunch of hard questions as well. So see you in the next one.